1005, TVD of 1000, 4075 at 4000 TVD, and then 7700 at 7500 TVD, and lastly 9275 of MD at 9000 TVD. Okay, and you can have this cumulative displacement and the angle calculated automatically. You can click plot. All right, so we have a deviated well in this case. Finish. Done. All right, so for the second section, we need to input surface equipment data. First, before completing this section, I want to show the picture to you. So I can click cancel first, and then, yeah, close first. Okay, so for this one, the average heat capacities, I will use the default numbers. Click done. Okay, yeah, there are errors because we still haven't input the data yet. So, okay, cancel. I want to show the case to you. Help, contents, and then our case is taken from this examples guide. This one, tutorial 31, modeling a surface multiphase pump. Open, and let's see the case. Pipeline. Okay, so this is our case. We have the platform here, or the rig, and this is our wellhead, 250 feet apart from the multiphase pump. All right, so this is the configuration, and this is the data table. All right, so you have manifold and pipeline, pipeline, and again pipeline, the pump, and again pipeline. We have pipeline here, here, pipeline, pipeline, and pipeline, and also pipeline, right? Okay, so this configuration is our case, and we will input this information to the surface equipment data input. So we can close here and edit the surface equipment, downhole equipment, and geothermal gradient. All right, so click done, or not done, we click edit. Okay, so for the surface equipment, you can follow me. I will maximize coordinate system, TVD and length, choke method, ELF, temperature of the surrounding, 55, 52 degrees Fahrenheit, with overall heat transfer coefficient of 8.5. And we start from manifold, TVD of 0, and then we will have pipe with length of 250, true vertical depth of 250, 4 inches, default roughness, and rate multiplier of 1. And again, open the drop-down menu. We choose pipe, 500, 475, 4 inches, default roughness, rate multiplier 1. And then again, the pipe. All right, you can go back in this video and you can see the picture again and the data table. And what I input here is actually the same with the previous data table I showed you in the help section. Okay, and then the next one, 1000 at the same TVD. All right, it is a horizontal pipeline, 4 inches, the same. And then again pipe. All right, we have this system, this multiphase pump and piping system on the surface, I mean on the bottom of the sea. All right, the surface of the bottom of the sea. All right, And then here we have 750 at TVD of 600, 4 inches pipe, default roughness. And again, we have pipe before we have the pump, 1000. And then at 600, again, horizontal piping, horizontal pipeline, 4 inches, default roughness, rate multiplier of 1. And here we have the pump. All right. Our multi-phase surface pump. All right, rate multiplier 1. And lastly, between the pump and the wellhead, we have the pipe with distance of 250 at the same depth. All right, with inside diameter of 4 inches, default roughness, and rate multiplier of 1. You can also check the pipe schedule, all right, in this catalog. Okay, close. And you can also check the plot. Again, we need to provide the data here because we have errors, right? Done. 52 degrees Fahrenheit, 8.5. All right. Okay, so this is the configuration, the pipe elevation plot, height above origin against distance from manifold. All right. Okay. So again, you can play back the picture I showed you before. This plot is actually the same with this, with the case with the picture I showed you. All right, so from here we can click done, done, and we go to this section, downhole equipment data section, Christmas tree at 600 feet. We have tubing. Here we have measured depth, 1000 with inside diameter of 4052. Default roughness, multiplier of 1, and we have subsurface safety valve with smaller inside diameter. Again, rate multiplier of 1, and we have another tubing down to 9,000 feet with the same inside diameter, default roughness, and multiplier of 1. And lastly, we have casing down to 9,275 with inside diameter of 6.4, default roughness, and rate multiplier of 1. All right, so far so good. Click done. Lastly, we need to input the geothermal gradient with overall heat transfer coefficient of 8.6. You can follow me. At 0 formation measured depth, the formation temperature is 60 degrees Fahrenheit. At 600, it is 40 degrees Fahrenheit. And at the depth of the reservoir, at reservoir depth, the temperature is, of course, as inputted already, 210 degrees Fahrenheit. You can click plot, finish, done. All right, so now you can check the summary. This is the big table. You can draw down hole. All right, Christmas tree, tubing, safety valve, tubing, and casing. Close, and you can also draw surface. Okay, so from manifold, piping, 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 and we have pump, and we have pipe here. Okay, and after the pipe, we have, as the picture shows you, the wellhead. All right, and we can click done, done, done. Now we need to input this data section, or you can see our well here depicted here. Now we double click here